Discrete information is stuff that is the result of counting. So like if I counted all the students in here, that's discrete information. You are discrete from each other. You don't blend into each other, right? You're not continuous. You're discrete, unique individuals with souls and humanity. Continuous information is the result of measuring. So, but if I took one of you, discrete individuals, and measured your height, for example, that would be continuous. Because you don't go like, so let's say you measured your height as you were growing. You don't grow like this. 1 foot, skip to 2 feet, skip to 3 feet, skip to 4 feet, right? First of all, that would hurt. Second of all, so it's like really a slow measurement, right? When you're measuring your height. And so that's continuous information. Discrete information can take only certain values. Like if I was counting you guys, the values would be 1, 2, 3, 4, 5, right? No negative numbers, for example. No half numbers. But continuous information can take any value in a certain range. So again, if I was measuring your height, you know, I'm 5'5", so if I had been measuring my height from when I was born, I was probably around 20 inches when I was born. So my height from 20 all the way up to 65 inches, that's a smooth, continuous measurement. And it can take any value in that range, anything in between. Discrete information looks like what? Dots, right? Yeah, it could be all over the place if it was a scatter plot. If it had a linear relationship, it would look like this. It can have different kinds of relationships. Whereas continuous information would look like smooth, with no breaks in it. As far as examples go, what's the example I already gave you for discrete? Counting the number of people, right, in the classroom. So discrete, an example would be number of students in class. But still staying with students, what's the example I gave you for continuous information? Of measuring your heights, right? Students' heights. Please give me a discrete information from your everyday life. Something that's discrete in your everyday life. Discrete, yeah. Then we got to talk about what's continuous about that. I don't want to do that. Eating breakfast. Go. What were you saying? Okay, let's talk about episodes. Well, let's talk about episodes of a TV. Let's talk about episodes in a series, okay? Think about a whole season of series. What's discrete about that? The amount of episodes. Episode 1, episode 2, episode 3. But what would be continuous about the episode? What'd you say? The time. The length of an episode, right? So discrete would be number of episodes in a season. But continuous would be the length of the episode. Thank you. I'm going to pause this for just a second. All right. So what we're going to do here, this is your other gold sheet that's not your calendar, okay? There are, I think, 6 different situations, and in each one we're given different pieces of the puzzle. It's not really a puzzle. Different pieces, and we have to fill in what's missing. So the first situation says, and this is where I feel like you're going to get bored after the 3rd or 4th one, but just stay with me because there's different kinds of stuff going on in each one. And then after this, you have a worksheet that turn in before you leave, and that should go real fast. So the first situation is student council earns a profit of $5 for each homecoming shirt sold, okay? Let's talk about, first of all, do you feel like that's discrete information or continuous? Discrete, right? Because those are individual things, the number. So over here somewhere, just write discrete on the outside of that. It's absolutely discrete. What depends on what? There's two things going on here. There's the profit and the number of shirts sold. The profit depends on the number of shirts sold. So the dependent information is the profit. I'm going to call that P. And then the independent was the number of shirts sold. I'm going to call that S. And we're going to talk a little more about function notation today. We're not going to write actual equations, but I do want to write the f of x part. If I named the dependent P and the independent S, this function would be, well, instead of f, it'd be P of S, not POS, which is something different and also not appropriate to put on the video recording. So P is dependent on S. The thing on the outside depends on the thing on the inside when you're writing your function notation. And then labeling your graph, what goes on the horizontal axis? Number of shirts sold. The S goes down here. And on the vertical is the profit, P. And let's think about how that graph would look. It's going to be straight because it's a linear relation. It's increasing at a steady rate. But like when I was telling you, if I was measuring my height since I was a baby, my height would have started around 20 inches or something like that. At 0 born, I'm 20 inches. But if I have sold 0 shirts, where does the profit start? 0. 0, right? So the first thing is going to be 0, 0. Right? 0 shirts is 0 profit, and then it's going to be a linear relationship from there. And we said it's discrete, so it's pieces of information separate from each other, right? Because we're not going to sell 1.5 shirts or something like that. All right, so we dependent, independent, we labeled our things, we did that, we did that, we did that. Okay. For the next situation, we're given the variables. Dependent is the price of a hotel stay, independent number of nights. These two problems are real similar. How would you explain the situation when you're given that information?
That would be the cost of a hotel stay scattered like by every night.
The cost of a hotel stay depends on what? The number of nights that you stay, right? You think, yeah, okay, so it's discrete. So discrete goes here. Explain the situation in your own words, however you want it to go. I'm going to write the price of the hotel stays depends on nothing. I'm not doing anything creative. It's just price of hotel stay depends on number of nights stayed. What letter do you want to call the price of the hotel stay? P? N for number of nights, okay? And so then when I come over here and I label it with my function notation, is it P of N or N of P? P of N, right? The dependent thing goes on the outside, the independent thing goes on the inside. And what goes along the horizontal axis? Number of nights. And the vertical one is the price P. How in what ways would this graph be the same or different from the previous graph?
It starts out at 0, 0.
Still starts out at 0, 0. Exactly. If you stay 0 nights, the price is 0. Yeah. They do that at the Marriott all the time.
Well,
That's why they had to make that announcement about don't go take your homecoming pictures at the Marriott. Because the kids are like everywhere and they're not even paying customers and it gets in other people's way. But prom you can, right? Because we all paid to be there for prom. So. I think we did everything for that situation, right? That situation, we're good with it? Which information are we given in this next instance? Graph information. Is that discrete or continuous? Continuous. Okay, so what is the dependent information here? Price. And what's the independent? Pounds of bananas. So I do have a question though about this one because it seems really similar to the other ones. Cost depends on the number of pounds of bananas. Why is this continuous and not discrete?
Because the bananas is different in every banana.
I feel that, yes. Because the pounds is different. Not every bunch of banana is going to weigh exactly the same, right?
Well, no, it's a bunch of bananas. I know you're talking about. You said singular bananas. No bananas a pound. Singular bananas. Amazing.
Okay, focus. That was enough. That was enough about the bananas. When you measure the weight of bananas, is it only 1 pound or 2 pounds or 3 pounds? It can be everything in between, right? It can be, so you put it on the scale and it tells you. So that's why it's continuous. So what would your situation be? Price is dependent on, or if we wanted to mix it up a little bit, we could just say H-E-B sells bananas by the pound. Yeah, there's a situation for you. What letter would you want for price? What about pounds of bananas? B? Like P? So when you go to name it, would that be P of B or B of P? P of B. Dependent is on the outside, dependent is on the inside. It's like peanut butter, P of B, which also happens to go nicely with bananas. This is my second period plug for grilled peanut butter and jelly sandwiches. Thank you. Yeah, he's here. Thank you. All right, so here we go with a new situation. No more about cost right now. Bob empties his swimming pool at a rate of 10 gallons per minute. So think about what is the dependent information and the independent. What's depending on what? I heard time. Time is something. Gallons. What about the gallons? Do we know how many gallons the pool starts with? So let's try and refine that a little bit. Instead of gallons in the pool, what's changing actually? The level, the water level. Okay, so we'll refine that a little bit. So which is dependent, time or the water level? Water level depends on time. What letter do you want for water level? W? And for time? Is function notation W of T or T of W? W of T. Dependence on the outside, independent on the inside. What's the horizontal axis? Time. So the vertical one is water level. W. Will this be continuous or discrete information? Continuous, right? Because it's a measure. But let's talk about how the graph is going to go. At 0 time, is the water at 0? It starts high at 0 time, right? Because before we started, the water level's high. So put it up here somewhere. Where will the water level be at the end of the time? At the bottom. So somewhere down here, after some time has passed, the water level will be 0. And did we say this is going to be dots in between or a straight line? Straight line. Yeah. Because it goes at a continuous rate, so it's a linear relationship. I want you to take a minute and do these last two by yourself, and we'll talk about it. Oh, by the way, for this last problem, the cost of the toll depends on number of axles. In case you don't know what's going on there, have you ever driven on a tollway, like with your parents or by yourself? Okay, it's a freeway where you pay to drive it because you can go faster or there's more lanes or whatever. And as you go through the tolls, you're either dropping money in or they're taking a picture because it's all big brothery, and they're sending you a bill that you have to pay online. But number of axles is like it's the thing that's connecting your tires, right? I don't know, JJ, right? Is that right? What an axle is? Connecting your tires. And so a regular car is a 2-axle. A big long semi-truck has more axles, and so you're paying more toll based on the number of axles. And the dots are random because this is not a linear relationship, right? It's more like a scatter plot. It's whatever cars are coming through. So take a minute and finish those out, and then we'll talk about it. Okay. I am pretty sure everyone got the last one correct, perfect. But I want to talk about the graph of the tree a little bit. Why would I graph my graph like this instead of a linear relationship? Talia? That's right. They don't continue to grow at the same rate, right? When they're young, they grow really fast, but then they pretty much max out on their height. They might still keep growing slowly a little bit, but not as fast as they originally do, right? And so they just grow like that.